We're talking about physics and rigid body in Unity. Physics in Unity is handled by built-in physics engine. Unity's built-in physics engine runs the physics for game object interactions and various effects such as gravity, acceleration, collisions, etc. Unity simulates physics to ensure that the objects correctly accelerate and respond to the collision's gravity and various other forces. To have convincing physical behavior, an object in a game must accelerate correctly and be affected by collisions, gravity, and other forces. Unity's built-in physics engine provide components that handle the physical simulation for you that behave passively in a realistic way. There are two separate physics engines in Unity, one for 3D physics and one for 2D physics. The main concepts are identical between the two engines, but their implementation is different. For example, there is rigid body component for 3D physics and rigid 2D component for 2D physics. Let's talk about rigid body in Unity now. Rigid body in Unity allows a game object to have physical behavior. It will interact with other game objects. The Unity physics engine only knows that an object is meant to be acted on by the physics if the rigid body component is attached to the game object. Properties of a rigid body: mass, drag, angular drag, use gravity, is kinematic, interpolate, collision detection, and constants. Let's see one by one what does these properties mean. Okay, let's talk about mass here. Mass is the mass of the game object. Drag is the air resistance value applied to the game object. Angular drag is the air resistance value affecting the rotation of the object. Is kinematic. If enabled, object will not be affected by physics engine in Unity. Interpolate. It is used to smoothen the moment of the object. Collision detection. It changes the type of collision detection on the object. Constants freezes moment and rotation on certain axis of the game object. So that's it, guys. Thank you for the session. We are going to create an example for rigid body. For the demonstration purpose, we are going to create a 3D game object which is going to be sphere, and we are going to apply rigid body to the sphere basically. Okay, so let's start with creating a floor which will be a 3D game object which is plane. So for that purpose, go to game object, go to 3D object and select plane here. Okay, right now the plane is not visible on the camera. To do that, just reset the transform value for the plane. Okay, and yes, it is visible in the camera. Again, let's create a 3D game object which is sphere. So go to game object, go to 3D object and select sphere here. Again, reset the transform for the sphere here. Okay, go to scene mode here and slightly bring the sphere above the ground. Okay, so this is how it should look. So the sphere basically stays floating in the air. Right now we have not applied any rigid body to the sphere. So let's stop running the scene and let's apply the rigid body to the sphere now. Click on add component, go to rigid body here, and yes, the rigid body component is attached to the sphere game object here. Let's run the scene again and let's see the output here. Okay, the sphere now falls on the floor. Let's understand the properties for the rigid body one by one. Okay, let's stop running the scene here. So mass here basically is the mass for the sphere. It is right now set to 1. Drag is the air resistance value applied to the sphere game object. Angular drag is the air resistance value again applied to the game object that will affect the rotation of the sphere. Okay, use gravity here is the gravitational force applied to the sphere game object. So if we check the checkbox here, or if we check the use gravity to true here, that means that the gravitational force is applied here to the sphere game object. Let's uncheck the use gravity here and let's run the scene again. Since we have set the use gravity property here to false now, it does not fall on the floor. Let's set the use gravity property to true again, and the sphere will fall on the plane game object. Okay, let's stop running the scene again. Is kinematic property here basically will define whether the physics engine will affect the game object or not. Let's set it to true here and let's run the scene again. So by setting is kinematic to true here, the sphere basically is not affected by the physics engine anymore. Okay, let's uncheck the property and the sphere will fall on the floor again. Collision detection is basically the type of detection, okay, that will act upon on the sphere. There are four options: discrete, continuous, continuous dynamic, and continuous speculative. Then we have interpolate. Interpolate is basically it smoothens the moment of the game object. Right now it is set to none. We have two options here: interpolate and extrapolate. We will understand this, or we'll learn more about this in the upcoming sessions. Okay, constraints property here is basically used to freeze the position or rotation of the game object on X, Y, or Z axis. Let's check Y axis here and let's see if the sphere falls on the floor or not. Okay, the sphere does not fall on the floor. It is again floating in the air. Let's uncheck the y-axis here, and yes, the sphere falls again on the floor. So this is how rigid body works on any 3D game object. So that's it, guys. Thank you for the session. In the next session, we'll see an example on how to move the sphere using a rigid body component. Thank you to the sphere. In this session, we are going to move the sphere using rigid body component inside the script. This session is going to be a three-part session. In the first session, we are going to create a texture and apply the texture on the sphere. Basically, we are going to create a material. What is a material? Material specifies the optical properties of the game object. For example, its color, whether it is dull or whether it is shiny. Texture is basically an image which is a layover or wrap around the game object, which again provides the visual effects for the game object. Okay, so to start with, let's create a folder here and let's create a material. To create a folder, right click here inside the assets folder, go to create and click on folder here. Rename the folder to materials. Materials. Okay, open the material folder, right click here inside the material folder again and select material to create a material. Okay, name the material as beach ball, or the name could be anything of your choice. Okay, we have created a material here for the ball. We need to apply the texture here for the ball now. So texture is basically, as I stated earlier, is an image. So we need to download an image from the internet. What we'll do here is we'll apply a beach ball texture here to our ball basically. Okay, so just click on the color map here. Okay, and just right click here and save image as. Okay, Udemy course images. Okay, so your image has been downloaded now. Just click on show in the folder, open your Unity, go to the folder here and just drag and drop the image here inside the material folder. Okay, that's it. Select the material again. Okay, click on albedo here. Okay, and just select beach ball color. So we have applied the texture here to the material. We need to apply this material to our sphere game object. So just click on the sphere game object here and inside the inspector window, just drag and drop the material here for the sphere game object. Okay, and that's it. We can see here material has been applied, or the texture has been applied to the ball here. So that's it, guys. Thank you for the session. In the next session, we will be creating a floor for the ball to move. Thank you so much. We are going to create a floor. We have already created a material for the floor here. Okay, and also we have downloaded the texture for the floor from the internet. Okay, let's apply this material to the plane game object here. In this case, plane is going to be our floor. We are going to have multiple plane game objects to create one big floor. Before creating multiple plane game objects, we need to create an empty game object and name it as floor. That will be the parent game object for all our plane game objects, because we need to keep everything organized. Okay, so let's right click here on the scene and create empty game object. Rename the empty game object here to floor. Okay, and just drag the plane object inside the floor game object. Okay, now we need to replicate plane here multiple times to create one big floor. To do that, just select plane game object and click on Ctrl D, and it will replicate the game object. Now we need to adjust the plane one game object here. To do that, basically we need to keep the move tool selected here in the editor and just drag this. Okay, does it look fine? Yes, it looks good. Yes, it looks good. Okay. Again, now click on plane one game object here and click on Ctrl D here. So we have created our floor. Okay, let's go to game mode and let's see how it looks. Let's bring the camera on the top to give it a better view. Thank you so much, guys. Thank you for the session. In the next session, we are going to move the ball using a rigid body. In this session, we are going to move the sphere using rigid body component attached to the sphere. For the demonstration purpose, we have already created a script rigid body move, and we have attached the script to the sphere game object here. Now to move the sphere, we will have to declare few variables here. Okay, float variable, vertical, float variable, horizontal. Okay, float speed equals to 5f, and rigid body RB. Okay, this rigid body RB is basically used to get the rigid body component from the sphere. To get the rigid body component, we will have to use get component function in Unity. Okay, so RB, we will have to initialize the RB rigid body variable using get component function. Component rigid body. Okay. Inside the update function, we have already seen this in the previous sessions. How do we use input.getAxis? So in this session, we are going to implement input.getAxis to move the sphere basically. But to move the sphere, again, we are going to use the rigid body component of the sphere. So now inside the update function, let's add vertical equals to vertical and horizontal equals to horizontal. Okay, let's apply if-else conditions here inside the update function to check whether we are pressing on the up arrow key, whether we are pressing on the down arrow key, whether we are pressing on the left arrow key, or we are pressing on the right arrow key. To do so, let's apply the first condition here for the vertical axis. If vertical greater than 0, RB dot add force vector 3 dot forward into speed. Let's apply another if condition. if vertical lesser than 0. Okay, so let's apply force to the rigid body again. Add force, vector 3 dot back into speed. So now let's apply conditions for the horizontal axis to check whether the player has pressed on the left arrow key or the right arrow key. Okay, to do so, if horizontal greater than 0, this condition will be for the right arrow key. Okay, so RB dot add force vector 3 dot right into speed. And lastly, horizontal smaller than 0, RB dot add force vector 3 dot left into speed. Okay, so the ball is moving now. We can increase the speed or we can decrease the speed. Okay, so for that purpose, we will have to declare two more variables here. Public game object camera. Okay, and then let's declare one more variable of vector 3. Let's name the variable as offset. This variable will be the distance basically that we're going to calculate between the camera and the sphere game object. Okay, so let's assign some value here to the offset variable. Okay, at the start of the scene. So offset equals to new vector 3 camera dot transform dot position dot x comma camera dot transform dot position dot y plus 1. Okay, we want to keep the camera basically slightly above on the y axis, and then camera dot transform dot position dot z minus transform dot position. So transform dot position is the position of the sphere here. Okay, so now we have set the value for offset. In the first condition here, if vertical greater than 0, let's add one more line of code here. Camera dot transform dot position equals to transform dot position is the position for the sphere, okay, plus your offset plus the distance. We'll have to replicate this code, okay, basically in all the if conditions here. Lastly, we will have to specify an else condition here as well, wherein what if the ball is not moving. If the ball is not moving, again we have to specify the same code here. Camera dot transform plus offset. Okay, so that's it. Let's save the script here and let's go to the editor. Okay, click on the sphere game object here. Just click on main camera and just drag the object and just place it here. That's it. Okay. Okay, so that's it. That's it. We have our camera following the sphere as well. So that's it, guys. Thank you so much for the session. I will see you in the next session.